presentation. My name is Alla, and I am a data scientist at SEB. For those of you who do not know what SEB is, that's a bank which was founded in 1856, and then with the main vision of giving service to enterprises. But this is not our vision, not the only vision we have nowadays. We give also services to different type of customers. We have not only large corporates and financial institutions as our customers, we also have SMEs and also private customers. We have millions of customers all around the world, but also mainly in the Nordics. And I would like to note that we have a lot of initiative in the bank to give a better service to our customers, no matter private customers or large corporates. Today, my main, if this works, I'm gonna, sorry? Oh. Yes. So one of our initiatives in the bank is a chatbot, which is called also AI, customer service or cognitive customer service or Aida or chatbot. I'm gonna use these, all of these names exchangeably, so you know that when I'm saying Aida, it's nothing than just a chatbot. We started to use this chatbot in 2016, and the idea was to give a better customer service to our customers. And when you go to SEB customer service and start to have a conversation, mainly chat, you are going to chat with high probability with our chatbot or Aida. And then she is going to help you in different processes and answering some of the questions. We also won a prize at Connected Enterprise Summit for the use of AI agent Aida. Aida is originally an IPsoft product, which its name is Amelia, and then when she comes to SEB, we teach her how to communicate in Swedish. At that time, she was able to only communicate in Swedish, and also we teach her, we basically taught her with the finance and banking stuff, so she could answer some of the questions and queries that if you go and ask her. And she also knew which questions she can answer, and for which questions she should escalate it to a human customer service. So when we started using Aida, the idea behind using Aida was that we are going to reduce the number of resources in the customer service, and also we are going to provide a 24/7 and faster service to our customers. So what happened is that we started launching Aida, but then we got some questions. Okay, what happened in the conversation between our customers and Aida? What our customers were asking for? And also, was the conversation successful or not? We got these questions and we didn't know what to do with that, because before our human customer service, people would just fill in the form right during the time that they were having conversation with the clients. So now we needed to create a pipeline, something like this. So we started from here, that a prospect customer would come and have a conversation with Aida, and then we would get the conversation text in Excel files. It's nothing than like a text Swedish conversation between a chatbot and a customer. And then in order to get to know how the conversation went, if it was successful, to extract the features, what people are asking for, is this any problem with other channels? People are complaining. Are they complaining about, I don't know, bank ID, or they're complaining about the app and so on? Some people in Aida team started to manually read the conversations and extract these features for the later use. So then they could use some other tools, for instance, Tableau, to get to know, okay, people are mainly asking about this question. Or people started to asking, I don't know, about login. A lot of people are asking about, I don't know, some other product that another bank just launched. So we need to update Aida with this type of information, or we need to, I don't know, figure out or solve the problem. As you can see, Aida, team task was to read the conversations, extract the features, label the conversation, and also update or teach Aida. So, which means that we basically reduced the number of resources in customer service. But then we needed to have more like people doing this manual job in some other department in the bank, which is like, we called it Aida team. So it got a like fancier name, but it was again some manual boring task. And also, even though we provided faster and 24/7 like service to our clients in customer service, but at the same time, the analyze time and also the follow-up and also these like updating Aida with new information and so on became like way slower. So what happened in our organization is that we used an AI solution which removed some boring tasks and created some other boring tasks. So we needed to fix this issue. We had some solutions. One is like, let it be as it is. We are going to have some people are going through the conversation, but it's fancier. We already got like awarded because of using AI agent. We are not going to go and say, hey, we got this like prize, but we give up. We are not going to use it anymore. So we decided to continue with Aida, but not with similar setup. Because the problem with the similar setup is that it cannot be scaled. At that time, we had just one Aida in the bank, and we needed, I think, 4 full-time employees going through the conversations and read them and extract features and do this manual work. So if you wanted to have like tens of Aidas in different parts of the bank going and having communication or conversation with our customers, it would not work. We couldn't scale it. We couldn't have like thousands of people going through the conversations. So as you may guess, we decided to fix it. And the way that we did is like, OK, if we go back and look at our pipeline, we have mainly 2 challenges, or from a data scientist perspective, we have 2 bottlenecks there. First of all, the way that we are getting the data. It doesn't work to receive the data a couple of times in a day in Excel sheets. You cannot handle the schema, basically. We cannot like do advanced stuff because the data would come and we had to store it somewhere locally and it wouldn't work. You don't want to have like data in Excel sheet and once it becomes kind of big, start working on that one. So we said, we are going to, first of all, onboard the data. We are going to create a pipeline which the data will be onboarded directly to our data lake. We have a data lake, and the data will be stored in a, let's say, distributed file system. It's like nothing, just a Hadoop distributed file system. So this pipeline is done, and then we get the data in like a semi-stream. So we get this data, it will be stored there, and then it's ready to do like cool stuff. The next thing is that we said, OK, we are going to replace this manual work with some machine learning task. So basically, we said we are going to have AI on top of an AI to get rid of some of the challenges we got because of using this AI. So that, as you can see, we have a data lake, and as I explained, the data is going directly after the conversation to a distributed file system stored there, and then we have our own model or script, which the data will pass through this one, and then Aida people start their job. They start looking at the let's say, statistics, and also they start to maintain or teach Aida with new type of like information and so on. So what I'm going to talk about now is mainly regarding that ML part, which you would expect me to talk about. But before that, let's take a look at one of the conversations. As I said, conversations are in Swedish, and they are like free text. They are unstructured, and as here you see that there are like some tokens here, Aida and Yog. Yog is like a client, and also in this case a human customer service took over the conversation, and this is the structure of the conversations when we talk about the conversations. And then talking with business people, we figured out a lot of features they are looking for. Yeah, never mind. A lot of features they are looking for is nothing than just some sort of regex stuff. Because Aida's like phrases or conversations are mainly coming from a set. So what you do is like you're looking for these keywords. You want to know that how many times Aida said, hey, I cannot help you because of this, or I cannot help you because of that. So that's the main, like, at that point, that was the kind of one of the main deliverables. So we can do it simply with a regex, like a stuff job. So we did it, and it was kind of successful, but then it was not the only thing they were looking for. They wanted us to build like a machine learning model, which does the labeling like itself, because they would read the conversations and label them as successful or unsuccessful. What we got was a set of 20,000 manually labeled conversations as successful and unsuccessful. The structure was exactly the same as what I've shown you. And then they basically, we couldn't figure out how they label the conversations. There are many people doing this or were doing this manual labeling, so it was kind of subjective. And so we needed to build a model, like a machine learning model, who is doing this, which is doing this task for us. So that's a binary classification, text classification, and as you can see, the data is kind of, it's not skewed, it's okay. Then our first attempt resulted in something like this. So as many of you would do, we started with something simple, but we got kind of a decent performance. So we used two types of approach. One is to use like vectorized features. Many of you may know this TF-IDF, to vectorize using different n-grams, and then it gives us a very granular like features. These features, then we use some sort of kind of simple model on that. So we use the logistic regression for these type of granular and features. And then we also use the extracted features from the conversation, and also we use some sort of more kind of advanced and sophisticated model. But one of the first like lesson I learned from this was that when I start using more advanced model on like granular like features, it starts to overfit. So I decided to, okay, we split it. We have like two types of features, more like in detail, less detail, and then I apply two different models. Then we can like use like combine the results and get the labels. We got 82% in terms of accuracy, and also on the area under curve, we got something about 80%. Then at this point of time, you want to try other things like a neural network and also more advanced stuff. Now you have something like you have something as a benchmark, so you want to move further. We had some idea that is it optimal to like looking at a conversation when you have two parties, they are talking to each other. We have a role in the conversation, and also we have turn in the conversation. In a continuous text, for example, if you are gonna classify reviews, like in Netflix, for instance, there will be one person talking about one topic, and then there is no turn. So if the person says that it was not good, it was not good. It doesn't matter where, it doesn't matter where the person said no or yes. But here we have some sort of question answer. You might say yes to one question and say no to some other question. So we were thinking about this, and also we started looking and doing some error analysis on the conversation text, and it seems like, yeah, then both role, who is saying matters, and also when in a conversation, or where in a conversation this phrase is said, it also does matter. So we had kind of rough idea, and then to have to implement some sort of recurrent neural network when we have multiple neural networks where they do this type of message passing. They do stuff, or like they receive an utterance from one person or one part of the conversation. They do stuff. They send their opinion about the conversation, or like a quantized or compressed version of what I received so far to the other one. The other one would receive the other utterance corresponding to, I don't know, Aida or client, and do the same thing. And they would do some sort of message passing between each other. And to the best of our knowledge, we couldn't find, or it was like almost nothing in the literature at that time. So what we tried to do is like, okay, let's collaborate with academia, and we kind of defined a master thesis project where Tres from KDH started working on this topic. So I just gave her, okay, this is a question, this is my rough idea. Go and find a solution, and that's something like this. So from now on, what I'm going to present is Tres work, and what I tried to do was to give like advice and this type of stuff. So she defended her thesis and started working now in Apple on Siri project. So she also went from text to voice. You can find her thesis and more detail on the what I'm going to talk in the link below. Yeah. So the final structure of the network became something like this. As I said, we have two streams, or we have two branches, one for Aida utterances and one for client utterances. What happens is that during a conversation, Aida says a sentence, and then the sentence is going to go to Aida LSTM. LSTM, in the first place, has no opinion about LSTM of the other side or client. It will do one run, let's say, and then sends a compressed version of what she believes to the other LSTM. And the other LSTM, now she has some ideas about the first utterance, which came from Aida. Now the other LSTM on the right-hand side receives some utterance from the client. Using the utterance and also the received information from the other LSTM starts to do one iteration and sends back these compressed version of utterance to the previous one. And they are going to doing this until the end of the conversation. It sounds like the way that we communicate with each other. I answer based on what I receive as a question, and also depending on what we have been talking before. So I kind of looking at the history of our conversation when I'm answering some question, and also I look at what you ask me right now. Then we found, okay, it seems it's better that we collect all of these compressed utterances that the LSTMs are passing as messages to each other, and do and concatenate all of them, and then use some sort of softmax in order to classify as 0 or 1. But at the same time, we had some sort of idea that, okay, when Aida says, for example, I don't know, it should not be exactly the same as when a client says, I don't know. Probably when the client says, I don't know, this is not our problem, and the conversation is successful. If the client doesn't know if he or she has, I don't know, DigiPass, this is nothing to us. But if Aida doesn't know something that she should know, then that's important factor. So our kind of rough idea was that, so if we have a vectorized, if you vectorized all the words in our corpus, the vector for single word, when Aida says, it should not be exactly the same as if this word was said by the client. So there should be a mapping. So for those of you that know the embedding, we mean that we thought the embedding should not be the same when Aida says something and the client says something. Our idea here was to use two different embedding systems, but we didn't get a big corpus of data. So we said, okay, we are going to use a pre-trained embedding model, and we work on that one. Then we add another layer, an attention layer, where the attention layer is to put different weights on specific words, if Aida says that one or the client says that one. So we use different types of models, like by LSTM attention, also the hierarchical attention network, which hierarchical attention network actually worked best, and the hand or hierarchical attention network is a network which puts weight in two layers. One is which utterance in a conversation should get more weight, and in each utterance or in sentence, which word should get more weight to classify the conversation. So here is the results of the classification task, and as you can see, I have different models. The model here means this model is LSTM, bidirectional LSTM, or a hand is what we put between embedding and the LSTMs. Without role means that we have just one branch. We don't care who is saying what. We just we have just one branch, and then we feed all the conversations to that branch. And also we have a case that we have role as well. So as you can see, the best performance we get is for the role dependent, where we have two branches, where we have hierarchical attention network, and then our accuracy went from 82 to 88, and also area under curve went from 80 to 94. But this is not the only thing that we can get from these type of models, like when you have attention layer or you have a neural network. You can also get other features. Also, we communicated these findings with the Aida people as well. For example, here you can see what are the words that gets most substantial average separation. For example, here, if client says ring, it gets way higher weight than if the Aida says ring. So you can see that two branches are not doing the same thing. So if you feed exactly the same word in two branches, after we train the model, they get different like embedding. So it seems like our role dependency is working. Some other like feature is that to see where the network is putting the most weight. We fed exactly the same like sentences to the model, to both those two branches, one for Aida, assuming that, okay, Aida says this sentence, or client says this sentence. And we can see that the weight system or the network is putting on the most important word, so also differs if Aida says or a client says. And we can also see the distribution of the weights in a sentence. Here, it shows that, okay, if we have a single sentence, where to put the most weight. So, and the green one is for Aida. It seems like Aida is saying most like informative stuff in the beginning of the conversation, and the rest is just, I would be happy to help you, and so on. And for the customer, it's some sort of different, in the middle of the conversation, or it doesn't matter that much, actually, because usually the clients, they would come and have like a very short answers. Aida would ask, hey, I don't know, nice to meet you back here, what is your question? And then you would say, bank ID. Something like this. So you can see that these type of models, they can also help us to know how this type of like labeling by our people are done. And also we can get more insights about what is happening between Aida and our customer. So, last but not the least, this is not the only case that we have some sort of researchers or collaborations with the academia. We usually, when we get these type of questions or we get some sort of projects, we would like to deliver something, but from some point, we might not be able to continue doing the research. And if you're also like me coming from a research like oriented background, you would continue and do more like cooler stuff and find something like optimal and so on. In our team, what we do in order to do that, we have like a great collaboration with academia. We have master thesis students, a lot of master thesis students, and also we have PhD students, like industrial PhD students, with the focus on the projects or the questions that we have in the banking. So that concludes the presentation, and thank you for your attention.